In this video, we're going to look at how permutations and combinations are used when calculating probabilities. If you have a good grasp of permutations and combinations, and the basic counting principle for that matter, then the probability really just takes those concepts and it extends it. Because as you will recall, probability is the number of ways a certain event can happen divided by the total number of possible outcomes. So that's what we're going to be calculating. It's just that in some instances we need to use permutations and combinations to calculate the total number of possible outcomes. So let's take a look at our first example. 3 cash prizes of $20 each will be awarded from among a group of 10 people. What is the probability that all 3 prizes go to someone in the Smith family, who are Tim, Becca, Sam, and Tabitha? So the first thing we need to decide is whether or not repetition is allowed. Well, these are cash prizes, and so we're going to assume, because again, it doesn't say repetition is allowed, so we will make the assumption that we're not going to give more than one prize to one person. Also, we need to think about whether or not order matters. If we're giving out 3 cash prizes of $20 each, there is again no advantage and no difference between being the first name drawn, the second name, or the third name drawn. So that tells us we're going to need to use combinations. Now, in this case, we want all 3 prizes to go to someone in the Smith family. This is our event E. This is the specific thing we're looking for. So this is 3 prizes to people in the Smith family. And our denominator would look like we just need to give the prizes to any 3 people. So how many ways can we do this? Well, knowing we want combinations, how many people are part of the Smith family? Well, 4 of them. And we are going to choose 3 of them to be awarded our $20 cash prizes. Overall, however, there are 10 people, and we are going to be selecting 3 of them to win cash prizes. So now we have our specific event. The number of ways our specific event can happen. 4 choose 3 means there are 4 ways we can select 3 people from the Smith family to win a prize. And then our denominator, 10 choose 3, is 120. Again, if you would like to reduce that to 1 over 30, you are free to do so, although it is not required. Let's take a look at our second example. Let's say we have 18 horses that are competing in a race. If you are a betting person, in order to win what is called the trifecta, you have to bet on which horses you think will finish in first, second, and third place. And you have to be correct. You have to get them right in the exact order. So what is the probability you will win the trifecta? Basically, what is the probability you will win a lot of money? Because if you can get the trifecta, that is worth a lot of money when it comes to betting. So first of all, think about, can we have repetition? Well, no horse is going to cross the finish line more than one time, so there is no repetition. Second of all, does order matter? Well, yes, it does matter. It says we have to figure out which one will finish first, second, and third, and we have to be right. So it doesn't count if we have the third place horse saying that they come in first. Okay, we have to get them right in that order. So what is the probability we will win the trifecta? So again, knowing that order matters, we want the number of ways that we win, that we get it right, and then the denominator is going to be the number of ways that 3 horses can finish in first, second, and third place. So if we're thinking about our horses, I'm going to think about first, second, and third place. There would be 18 possibilities for which horse could cross the finish line first. After that horse crosses the finish line, there would be 17 available horses that could finish in second place. And then finally, there would be 16 horses that could finish in third place. Multiplying those together, or if you prefer, taking 18 NPR 3, we get 4,896 different ways that our horses could finish in first, second, and third place. Now, for the numerator, this is how many ways we win. Well, that means we have to guess correctly. So we have one chance to get the first place horse right, one chance to get the second place horse right, and one chance to get the third place horse right. In other words, whatever we choose, that is our one chance of winning. And so the probability we would win the trifecta is 1 out of 4,896. Moving on to the next example. We are going to be dealt 5 cards from a standard deck of cards. If you need to pull up a deck of cards to reference for this question, please feel free to do so. So what is the probability we are dealt exactly 2 red cards? So when it comes to the probability, again, specifically what we want in our hand is 2 red cards. But beyond those 2 red cards, remember we have to have 5 cards in total, okay? So it is not just enough to have 2 red cards. What we want is we need 2 red cards and we need 3 cards that are not red cards. Or if you would like to say black cards, that works too, okay? Because we need a total of 5 cards. So again, we'll have 2 cards that are red cards, and then we'll have 3 cards that are black cards. Not really sure that black will show up super well, but I think it'll work, okay? Now, when we think about our denominator, what is happening in general? Well, in general, we are being dealt any 5 cards from the deck. So when it comes to calculating this, if we need 2 red cards, and order does not matter, okay? It doesn't matter the order you're dealt the cards. Most of the time people get their cards and then they put them in the order they want them in, but it doesn't matter the order that they're given to us. And repetition isn't allowed. We're not going to keep putting the cards back in the deck and reshuffling. So there are 26 red cards. We are going to choose 2 of them that will be in our hand, and times there are 26 black cards or not red cards. We will be selecting 3 of them to put in our hand. And then the denominator is, out of the deck of 52 cards, I am choosing 5 of them to put in my hand. So calculating 26 choose 2 times 26 choose 3, we end up with 845,000 different hands that would contain 2 red cards and 3 black cards. 52 choose 5 is 2,598,960. So this is the probability you would be dealt exactly 2 red cards. There is absolutely no need, in my humble opinion, for you to reduce that fraction. So you can leave it that way. That would be exactly what I would want you to submit as an answer. If it says report your answer in lowest terms, you would need to reduce, or decimal form, you can divide and turn it into a decimal. But again, most of the time you can stop right there. All right, here's a similar question. You are dealt 5 cards from a deck. What is the probability you're dealt exactly 1 ace? So now if we think about what our hand might look like, we're going to have 1 card that's an ace. And then we have to have 4 other cards in our hand that are anything except aces. Okay, we want 1 ace and 1 ace only. Then we're going to have 4 other cards that are not. So we want 1 ace and 4 not aces. Again, our denominator is, in general, we're being dealt 5 cards from a deck. So our denominator is we are being dealt any 5 cards. So now let's go ahead and set up the mathematical expressions that will help us calculate this. For 1 ace, there are 4 aces in the deck. We are choosing 1 to put in our hand. And times, there are 48 cards in the deck that are not aces. We are going to choose 4 of those to put in our hand. And the any 5 cards is there are 52 cards in the deck. We need to select 5 to put in our hand. So 4 choose 1 times 48 choose 4 is 778,320 different hands that would have exactly one ace over the 2,598,960 different 5-card hands that exist. And one last example. 10 people enter an art contest, and Abby is among the entrants. If prizes are awarded for first, second, and third place, what is the probability Abby places in the top 3? So in this case, again, we will not have any repetition because they're entering a contest, and so 3 different people will win. But there is the matter of order is important. Okay, order is absolutely important. So what we need to do is think about the number of ways that Abby could end up with one of the prizes in the top 3, and then that other people could end up winning prizes. So Abby, if she is going to be taking one of these positions, okay, so this is not necessarily first place, this is Abby here. Okay, Abby in this case would have 3 options because she's going to be in the top 3. She could win first place, second place, or third place. So that gives us 3 choices or positions that Abby could place in. Okay, now for the remaining 2 spots, it doesn't matter to us who it is. It can be anyone except Abby. So there's 10 people total. Abby's won a prize. There would be 9 people left who could win one of the other 2 prizes, and then 8 people left for who could win the third or the third prize. It doesn't have to necessarily mean third place. Okay, so that is the specific thing we want to happen. We want Abby to win one of the 3 prizes. So there's 3 choices there. Then we have 9 different people we could award another prize to, and 8 people for the last prize. Overall, if we think about what's going to happen here, anyone could win first place, anyone could win second place, or anyone could win third place, again, as long as repetition isn't allowed. So we would have 10 options for who could win first place, 9 options for who could win second place, and 8 options for who could win third place. Now, if you want to calculate this the super quick and easy way, one thing you might notice is that with our fraction, we have a 9 and an 8 in the numerator and the denominator. So we can actually cancel those out, and we can end up with 3/10 pretty quickly as our answer. If instead you multiply 3 times 9 times 8 and come up with 216, and then in your denominator you come up with 720, that's perfectly acceptable too. But whenever I see things like that, I always find it simplest to go ahead and cancel out my like terms. So in conclusion, whenever it comes to calculating probabilities, what you need to think about is not just the basic probabilities that we have been doing in the past, but you really need to think about whether or not repetition is allowed, whether or not you can use a permutation or a basic counting principle is how I typically think of it. Think of it like the blanks, because order does matter. It is important. It makes a difference. Or whether you should use combinations because order is not important. It does not make a difference in the scenario. And then calculate the specific event that the question is talking about. How many ways can that occur? And then look at it as also a very general event. So instead of Abby winning one of the prizes, for example, we just need to know how many ways people can win 3 of the prizes. Make it as general as possible. That's the denominator.